Hey everybody, welcome back again to another edition of Geometry. It's Mr. A here, and today we're in section 6.5. We're going to talk about rhombi and squares. Rhombi is just plural for a rhombus, but it's kind of a funny sounding word, isn't it? Rhombi. All right, well anyway, let's get started. Today our objectives, we're going to recognize and apply the properties of rhombi and squares. And then also we're going to determine if quadrilaterals are rectangles, rhombi, or squares. That's coordinate geometry, okay? I know you really look forward to the coordinate geometry stuff. All right, so let's start out with a rhombus is a parallelogram, okay? So key thing here, a rhombus is a parallelogram. You know, so again, that's why I've got the 3 asterisks here to say, hey, this is really important. All the things that apply to parallelograms also apply to a rhombus, and so therefore both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, consecutive angles are supplementary, which means they add up to 180, and the diagonals bisect each other. So that all still happens with a rhombus. Well, what's different with a rhombus? Well, here's what's different with a rhombus. A rhombus has all 4 of its sides congruent. Okay, so that's a key thing there. Basically, a rhombus is just a parallelogram where all 4 sides are the same. Okay, that's it. There's a couple other things, and I'll show you here in the next slide so you can see it visually. The other thing is it has diagonals that are perpendicular. So the diagonals will make a 90-degree angle. And then the other thing is the diagonals bisect a pair of opposite angles. And again, I'll show you in the next slide here. All right, so what do those things mean? Well, so if you look at it, here's a little diagram here of a rhombus. And so the first thing that we said was remember the sides are all congruent. So that means side AB is congruent to BC, which is congruent to DC, and AD. All 4 of those sides are the same in a rhombus. Okay, all the other rules still apply that parallelograms did. The second thing was that the diagonals are perpendicular. So here in this one, when you draw the 2 diagonals, it makes a 90-degree angle here. Okay, so that's another key thing that you can possibly use when you're solving problems with rhombi. The other thing is the third one there on the list was that the diagonal bisects a pair of opposite angles. Okay, so what that means is if you look on this one here, here's our diagonal PR, and what it does is, remember one thing about parallelograms are that the opposite angles are congruent. So this whole entire angle R and this whole entire angle P are congruent to each other. And in a rhombus, this diagonal splits those in half, exactly in half. It bisects it. And so what that means is angle 1 and angle 2 are congruent to each other. But also angle 3 and angle 4 are congruent to each other as well. And all 4 of those, 1, 2, 3, and 4, are all congruent to each other individually. And the other diagonal cuts angle N and angle Q into 2 pieces, and so 5, 6, 7, and 8, all 4 of those are also all the same as well. Okay, so when you have a rhombus, not only will the entire opposite angle be congruent to each other, but also the diagonal will split it up, and each one of those will be equal to each other and the ones on the other side. Okay. All right, let's look at first example here. So rhombus WXYZ intersects at V here. So the measure of WZX, that's this angle right here, is 39.5 degrees. And we want to find ZYX. So what's ZYX? That's ZYX is this whole entire thing here. Okay, that's what we're going to try to find. How can we do that? Okay, well, there's probably a few ways that you could approach this. As I've said before in math, there's usually not only one correct way to do it. There's many ways, but here's maybe easiest way that I think of. If this is 39.5 here, remember this is a rhombus, and so this diagonal bisected this angle, so that means this is also 39.5 degrees. Okay, so that's 39.5 and 39.5. And so that means altogether, this whole thing here, I'm not sure how to show this here, this whole thing here is 79 degrees when you add these two together. Okay, so this is 79 here, this whole entire angle Z. Well, it's a parallelogram, so wouldn't this whole entire angle over here, angle X, also be 79 degrees? That whole thing? So this whole thing here and this whole thing are both 79. Well, how many degrees are in a quadrilateral? Remember we talked about that before a couple chapters back. There's 360 degrees. So what I can do is I can take the total of 360 degrees, I can take away that 79 and take away that 79. So minus 79, minus 79. All right, let's see what we got there. 360 minus 79, minus 79. I'm going to move over here. Okay, so what that equals is 202. So what's left between the whole entire W and the whole entire Y is 202 degrees. Well, doesn't the whole entire angle also have to equal W, have to equal Y? Yes. So they both have to be the same. So if I have 202 left, all I have to do is just divide that by 2, and each one of those is 101 degrees. So in this case, the measure of angle ZYX would be 101 degrees. If you wanted the measure of ZYV or XYV, you could just divide 101, divide that by 2, and that would tell you each one of those individually. Okay, cool. Example 1b. How about this one now? WX is 8x minus 5. WZ is 6x plus 3. We want to find x. Okay. Well, remember, in a parallelogram, the opposite sides are congruent. And so, but we don't have that available to us on either one of these. But remember, this is a rhombus. And in a rhombus, all sides are equal to each other. So the easiest thing we can do here is say, oh, well, 8x plus 5 has to equal 6x plus 3. They're right next to each other. If it was a regular parallelogram, we couldn't do this. But since it's a rhombus, we can. So minus 6x minus 5. So this is going to be 2x and equals a negative 2. Divide by 2. X is negative 1. And okay, you know what I did wrong? Okay, I'm going to explain something here. Why did I stop and think about that for a minute? I was looking at this x equals negative 1, and I thought, that seems a little strange. Now let me plug it in here to check it. And when I plugged negative 1 in here to double check this, these numbers come out to be negative. That's not good. We can't have distance that's negative. So what I noticed was when I went to set up my equation, what did I do? The equation here is 8x minus 5 and 6x plus 3. What did I write in my equation? 8x plus 5. So I messed that up when I recopied that down. So this should have been minus, which would have made this plus 5x, or plus 5 and plus 5. Then I would have had 2x equals not negative 2 here, but 8. And then 8 divided by 2 would make this 4. How about that for turning a negative 1 into a 4, huh? So that seems a little more like what we would expect there. When you plug that in, that does make those equal. So that's a good case to be made for double checking your work and paying attention. Don't always just blindly answer. If it seems weird, double check it. Okay, so x equals 4 there. All right, example 1c. ABCD is a rhombus. Find CDB. So CDB is this angle right here. trying to find this one, if ABC is 126. So we're trying to find this one here. If ABC, this whole thing here, is 126. So that one is 126. Well, remember, if this whole thing is 126, this also has to be 126, and this diagonal will bisect each of those angles. So all we have to do is 126 divided by 2, which would equal 63. And that looks like that would be letter B, and it is. All right, good. All right, squares. Let's talk about squares now. This is an example of a square I've got over here now. And first of all, a square is just a parallelogram, and it has 4 congruent sides. Oh, well, isn't that the same thing as a rhombus? Yes. But in addition to the 4 congruent sides, it also has 4 right angles. Now, in the example that I put over here, that's not drawn in, but when they say 4 right angles, it would be like this is a right angle, that is a right angle, that's a right angle, and that's a right angle. Okay, so a square is just a parallelogram, but it has 4 congruent sides. All 4 of these sides are congruent, and all 4 angles are 90 degrees. So key thing here to keep in mind, and that's why I picked this one with all these diagonals here, a square is going to have all the characteristics of a rectangle, but also a rhombus. And so what that means is, remember a couple of things here, that in a rectangle, the diagonals are congruent. Guess what? In a square, the diagonals are congruent, so therefore, if they also bisect each other, you know, it's got these little red marks here, all those 4 are the same. Also, it has all the characteristics of a rhombus, so therefore, it's going to make a 90-degree angle in here with the diagonals. It's also going to bisect each one of these angles, but since each one of those angles has to be 90 degrees, what's each one of these small angles? Every single one of these small angles is going to be 45, 45, 45. All of these are 45 degrees. I'm not going to write them all in. Okay, so it's going to have all those characteristics. So here's kind of a fun way to look at this. This is a little Venn diagram. If you notice, this big box is the world of parallelograms. You notice here's a parallelogram over here. Hey, all right, here's another one. But remember, weren't rectangles also parallelograms? Yeah, well, there they are. They're in the big box. Rhombi, they're parallelograms, so they're in there, and squares are. Well, as you can kind of see, rectangles, squares, and rhombi, it's just breaking down a parallelogram into more specific. So a rectangle means that you have 4 right angles. Well, here's a couple of rectangles, but isn't a square counts as a rectangle too, because it has 4 right angles. So all of those are enclosed in a big circle. And rhombi, remember, all 4 sides are equal, are congruent, but a square is as well. So then you have to have the rhombi circle including the squares as well. So you notice the square is partially, it's in the rectangle oval, but it's also in the rhombi oval as well. And so so that's what I was saying before, is the square, it has the characteristics of a rectangle, but also a rhombi. So what I like to say is, I like to say, hey, you know what, if you have a rectangle and a rhombi and they get together and have a baby, it's going to be a square. Okay, so a rectangle and rhombi get together and it's going to be square. Okay, cool. All right, let's take a look at a quick example here with squares. Here's ABCD. It's a square. AC, this whole thing from A to C is 10 inches. So this whole thing here is 10 inches. Find OB. So we want to find this distance right here. Okay, well, remember, just like in rectangles, the 2 diagonals are congruent. So that means that DB also has to equal 10 inches, right? And since this is a parallelogram, the diagonals will bisect each other. And so that means that if you just cut DB in half, It's the same thing as cutting AC in half, and so that means OB will equal 5 inches. Okay? Because again, remember all of these, if you remember in a square, all of these are congruent, and so if you just divide 10 divided by 2, you get 5. They're all going to be 5. All right, one more here. What about AB? Well, this is kind of fun, but remember, in a square, that makes the diagonals are perpendicular, so that makes it a 90-degree angle in there. Well, we just figured out here that OB is 5 inches, and AO would also be 5 inches, right? Both of those would be 5. If we want to find AB, boy, how would I do that? I could say, hey, what if I knew the opposite side? Nope. What if I knew one of the other sides? Nope. How else could I do it? Well, remember the Pythagorean theorem? The Pythagorean theorem is what? A squared plus B squared equals C squared. Since we have a 90-degree angle, we have a right triangle, and we can use this theorem. Remember, A and B are the two sides that make the 90-degree angle. So the two 5s, 5 and 5, are A squared and B squared. So we're just going to say 5 squared plus 5 squared equals C squared. And again, C would be the AB length. So this would just be 25 plus 25 equals C squared. That's 50. How do we undo squaring something? Take the square root. So take the square root. And so that means C would be the square root of 50. If we want to get a, I'll just punch it into the calculator here. Square root of 50 is approximately, so this means AB would be approximately, I'm going to round it to 1 decimal, so 7.1 inches. Okay? So if it asks you anything about degrees, you know the whole thing's 90, and each one of these by themselves are all 45. So that's pretty simple. All right. Real quickly here, this is a few things here that the book had talked about. You know, we've already talked about this one, but this is just the opposite of that. If you have perpendicular bisectors, you know it's a rhombus. If you know that the angles are bisected, you know it's a rhombus. Here's what I wanted to really mention, though, was since all 4 sides in a rhombus are congruent, in order to know that you have a rhombus, all you have to prove is that 2 right next to each other are congruent. Because since it is a parallelogram, opposite from that will automatically be congruent, and opposite from this one will. So if you know you have a parallelogram, all you need are 2 consecutive sides, which is kind of interesting. And then, of course, finally here, kind of what I was talking about before. If a quadrilateral is both a rectangle and a rhombus, then it's a square. So if it has those characteristics of both of those things, then it'll be a square. All right, so here's what we're going to finish on today. Coordinate geometry. It tells us already that ABCD is a parallelogram. Okay, so we don't have to, that's not something that we have to prove like we've done before with some of our coordinate geometry. We don't have to first prove that it's a parallelogram. So we already got that covered. So all we have to do is think about what's the difference between a rhombus, a rectangle, and a square. And again, there could be several different ways to do this. But let's think through and think about what's different between maybe a rhombus and a rectangle. And you say, well, a rhombus has all 4 sides are congruent. Okay, but a rectangle doesn't necessarily. If you use that method, you wouldn't have to find the distance of all 4 sides, because as I mentioned in that last slide there, if it's a parallelogram, we already know that the opposite sides are congruent. So all we'd have to do is show that 2 consecutive sides were congruent. That would involve the distance formula. Okay, we could do that, but that's not one of my favorites. Is there another thing that I could think of maybe that's different? If you think, well, you know, one thing that maybe is different about these things, rectangles and squares both have 90-degree angles. Hey, that's something. Well, how could I show, let's say that angle B here was 90 degrees? I could use the slope. I could use the slope formula. And remember, if you have a 90-degree angle, those are perpendicular lines. And so if we have perpendicular lines, that means our slopes are negative reciprocals of each other. Oh, hey, that's not bad. Slope. I like slope. Okay, let's do that. So remember the slope formula, y2 minus y1 over x2 minus x1. Okay, that's our slope formula. So yeah, let's do the slope of AB and BC. We'll do that one up here, this one up here, and we'll look at those two slopes. All right, so the slope of AB would be, I'll use this as 2. So y2, 3 minus a negative 1, so 3 plus 1 over negative 1 plus 2. So it looks like that's 4 over 1, or just 4. And then let's do the slope of, actually I'm just going to do it down here, the slope of BC. So if we're going to do BC then, I'm going to go 2 minus 3 and 3 plus 1. So this would be a negative 1 over 4. Hey, look at that. Those are negative reciprocals of each other, aren't they? Okay, great. So what we did here was we showed that this is a 90-degree angle. If that's 90 degrees, they all have to be 90 degrees in a parallelogram. So that means that the one thing that we proved here was this is not a rhombus. So what we've proved so far that it's not a rhombus. It could be a rectangle or it could be a square. Okay, so we've got one more thing to prove here. We got to figure out if it's a rectangle or a square. So let's think again one more time. What could we do? What's different between a rectangle or a square? Well, again, as I mentioned before, you know, a square, the two consecutive sides will be the same length, whereas a rectangle they won't, but that's distance again. Is there anything else? Well, the diagonals for a rectangle, actually that's the same for both a rectangle and square. They have to be congruent, so that's the same either way. What would be different though? What could be different? In a square, the diagonals would have to be perpendicular, but in a rectangle they are not. So we say, hey, well that's, I'm going to draw it here. So that's diagonal and diagonal. That means, hey, let's figure out if this is 90 degrees. Hey, if that would be slope, just like what we did. So this time, what can we do? We find the slope between BD and AC. Okay, so BD. So let's find the slope of BD. And so that's going to be negative 2 minus 3 over 2 plus 1. So negative 5 over 3 it looks like. And then again, now let's do AC. And so on AC we'll go 2 plus 1 over 3 plus 2. And so this would be positive 3 over 5. Are these two negative reciprocals of each other? That's a negative sign there. I kind of almost lost it. Whoops, that's a negative sign there. So yes, these are negative reciprocals. So that means this is 90 degrees as well, which happens in a square, not in a rectangle. So this is not a rectangle. So what we just proved here is this has to be a square. Okay, that's it. So that's it for rhombi and squares today. Hope you enjoyed that, or at least tolerated it. That's all for today. We'll see you next time. This is Mr. Anderson signing off. We'll see you later. Bye.